Now we're going to move on to changes in the endocrine system. We've already alluded to the role the endocrine system plays when we talked about estrogen and bone mass, and also some of the anabolic hormones that relate to muscle preservation. But there are a bunch of things that change in the endocrine system. Very often, though, the effect isn't necessarily on the gland that produces the hormone itself. The way the endocrine system works is there are chemicals that are produced within glands of the body, released out into the bloodstream, and have a destination, a target tissue that they go to. And once they interact with that target tissue, have a very profound and powerful influence on that particular cell or that tissue's function. And what happens, although many glands aren't substantially changed with age, we actually see that the target tissues aren't as good at detecting or allowing those hormones either to bind to their cell membranes or into the cells themselves, probably due to some of those cellular changes that we talked about with age. So it can best be illustrated with the disease pathology of type 2 diabetes. Now, the pancreas produces the hormone insulin, and insulin is the primary storage hormone within our body. So once we eat food or otherwise take in glucose, we're able to see an increase in blood glucose levels, which then stimulates the release of insulin from the pancreas. Then that insulin goes and binds to the cell membranes of either muscle cells or fat cells or some other cells of the body, and help then allow for glucose to be brought into those cells in order to assist with energy production. Well, with age, what happens to a lot of people is that their target tissues, the muscle tissue and the fat tissue, they actually become insensitive or unaware of the fact that insulin is floating around. And as such, we don't take up the glucose very well, and therefore we'll have high elevated glucose levels, which is the condition that we call diabetes. So some of the hormones that we are really interested in as far as the aging process is concerned is, again, estrogen. Estrogen, the primary female sex hormone. Incidentally, males produce estrogen as well, just in much smaller quantities. Estrogen, when it begins to decrease its production and ultimately come down to zero from the ovaries, a female experiences menopause, that period of time where not only do we see big decreases in bone mass, but estrogen has a strong protective effect on the heart. And many females prior to menopause have an incredibly low risk of heart disease due to the protective effect of estrogen. Well, once a person reaches menopause, that protective effect goes away, and ultimately, older females most commonly succumb to a much greater degree than anything else to cardiovascular disease. Then we also have the decreases in the production of testosterone by the testes on males, and also females produce testosterone as well in the ovaries. And we see that slowly but surely decline as an individual ages. And once an older adult gets to about the age of 80 or so, we notice that their endogenous or their internal production of testosterone decreases to such a point that they no longer can maintain as much healthy muscle tissue as they could before. We call that male menopause or andropause. And unfortunately, male menopause, that period of time, is highly linked to the development of sarcopenia because they no longer have a stimulus to maintain muscle mass, and they begin to lose their function because they don't simply have the muscle capabilities to perform some of those activities of daily living. Then we move on to growth hormone, which is another protective hormone for muscle tissue and other tissues of the body, released by the anterior pituitary. It begins to decrease significantly after the age of 70. So we again see pretty substantial effects on being able to maintain muscle protein status. And then finally, we see reductions in thyroid hormone, which we talked about a bit more, which stimulates metabolic rate. So for many older adults, we see their metabolic rate slow down because of the vast reductions in the production of thyroid hormone or thyroxine within the body. Then lastly, we might think that if the body starts to actually slow down the production of all of these hormones, why don't we just replace them, do some hormone replacement? And actually, there are a lot of people out there, physicians, that are making a lot of money doing anti-aging treatments of people that involve the administration of synthetic hormones into the body. Well, the problem with that is that the body tends not to respond real well. when it's injected with a hormone that is from outside of the body. And very often that can be associated with significant tissue damage and dysfunction within the body. In fact, for females, for a very long period of time, after they go through menopause, they used to be put on a hormone replacement therapy, where females would be given a form of estrogen. And that was meant to protect their bone structures and keep them at a low risk of heart disease. Well, it looked really good, and there were literally millions of women that were on hormone replacement therapy until they started to recognize through these trials, these research studies, that it greatly increased women's risk for breast cancer and uterine cancer and other reproductive cancers, just bad news stuff, because the body just didn't quite deal with being administered a synthetic hormone very well. And you know, personally, when I think about it, I think that we can illustrate it as well. I am not a New York Yankees fan by any stretch. I am from Boston, so I'm a huge Red Sox fan. And it just came out, Alex Rodriguez admitted that he had taken a banned substance, a steroid, at some point in his life. And I think that perhaps it affected, because artificial hormones do affect the body in different ways, it could have perhaps even caused him to decide to get involved with that whole Madonna thing, which I just don't get. So I'm going to attribute that one to synthetic hormone administration. We'll now turn our attention to changes in the immune system with the biological aging process. And you can see those creepy crawlies aren't exactly things that we want in our body anytime soon. And the way our body works with immunity is that we have both specific and non-specific immunity. In other words, we can mobilize the immune system to attack whatever comes into the body, but we also have the capability to remember some things that have bothered our body previously and infected our body previously, and then we can mobilize the immune system specifically to deal with those particular issues even more effectively. So what happens with the aging process is that we actually slow down the production of the cells called T cells that are responsible for non-specific immunity, that just respond to any foreign antigen or thing that comes into our body. And then we also notice that the body reduces its production and its effectiveness of its B cells. And the B cells are those cells that produce the antibodies or proteins that remember specific diseases, and what they'll basically do is they'll attach on to whatever that virus or bacteria or foreign substance would be, essentially tagging it for destruction. So the changes with both the T cell and the B cell in the reduction in production and sensitivity of those cells results in a general reduction in immune response. And typically we notice that older people tend to stay ill longer. They have more difficulty generating a fever response in order to fight infection. And a fever response is actually a positive effect because it ramps up the activity of the immune system. And then finally, we tend to see that these antibodies that are produced by B cells sometimes start to go a little bit haywire. They start to interpret parts of our own body as foreign substances, and we end up mobilizing our own immune system against our body's structures. And there are many autoimmune diseases that we're aware of, and one we'll talk about a bit later is rheumatoid arthritis. So then finally, the last bodily system, we're finally going to make it. The last bodily system we're going to talk about is the integumentary system, changes that happen to basically the skin. It's a fancy name. So as we age, hopefully we don't end up looking like these guys, the Blue Man Group. You know, I'm sure they make a lot of money, but you have to wonder if this is really good for them to be painted like that day after day, month after month, year after year. But some of the changes that occur within the integumentary system, or the skin, include that the layers of the skin, which are a number of dermal layers, they actually get thinner because the cell replication of the dermal layers slows down quite a bit, so we don't have as many skin cells. And also those connective tissues that pretty much adhere those dermal layers together get a lot thinner as well. So a lot of older people will take on almost a translucent appearance with their skin. It almost looks like you can see through their skin. It's kind of an interesting appearance. Additionally, we see that wrinkles form on the surface of many people's skin. And that's primarily due to an increase in, again, this kind of collagen, this connective tissue that's produced. And collagen ends up bunching together, usually along lines of stress. So it kind of bundles together, and then between them there'll be these crevices that we see as wrinkles. Some other functional changes include a decrease in a certain pigment that we call melanin, which is produced by specialized cells within the dermis. And melanin, which is responsible for absorbing some of the ultraviolet radiation that we get from our environment, melanin begins to decrease in production as we age. So we see two things happen with that. Number one, older people tend to take on kind of a pale or almost pasty appearance. And number two, it makes them much more at risk for sun-related damage. They tend to burn much more easily. They're at a much greater risk for skin-related disorders. And many older folks, because of that, tend to stay out of the sun or just put on layers and layers worth of sunscreen. Now, those issues lead to problems with vitamin D production, which is needed by the body to absorb calcium in the intestine. And vitamin D is primarily gotten, if not through fortified things in our diet or supplementation, being exposed to the sun. So these are things that kind of compound upon each other that might affect older adults. Additionally, we actually see the reduction in blood flow. Some of the blood vessels, the capillaries that run through the skin, become non-functional. We're not able to get as much blood to the skin to radiate out heat from our body to the environment. Additionally, sebaceous glands, or glands that produce sweat, begin to slow down their function as we age, and therefore our skin doesn't get as sweaty, and we're not able to evaporate sweat off the skin, which is the body's primary method of thermoregulation. So ultimately, we see older adults being at much greater risk for heat-related illnesses. And really, any time that there's a major heat wave that comes through, the sad thing is you always hear that older adults are the ones that succumb because they have major issues with thermoregulation. And then finally, the skin undergoes a number of changes related to the accumulation of what we call photoaging. Now, photoaging is the changes in the skin due to exposure to ultraviolet radiation. That's not exactly an intrinsic process, but it is very common, and it results in many older adults being at greater risk for skin diseases because over the years they have been exposed to these large accumulations of ultraviolet radiation. Okay, we're going to transition now from the systems of the body that we traditionally think of as our systems to our sensory systems and some of the age-related sensory changes that we see with older adults. And they are actually fairly numerous. And to be honest, the sensory changes that an older adult goes through tends to be more substantial in their functional consequences than many of the other systems-related changes, because your senses help determine how you interact with and respond to your external environment. And many older adults have a very difficult time getting good sensory information into the central nervous system and then processing that information. So when we talk about the sensory systems, we tend to think about sensory, the ability for sensory function and perceptive function, or what are senses and what are perceptions. So senses would be the ability to gather information from either the external environment or the internal environment of the body. And then perception is how the brain or the central nervous system responds to or interprets or reacts to that sensory information coming in. We're going to limit our discussion today primarily to just what the sensory changes are, particularly when it comes to vision, hearing, and proprioceptive changes or internal sensory changes of the body. But recognize there can be some central nervous system changes, those perception changes as well. Let's first start with changes in vision. So we'll take a look at the anatomy of the eye. The eye is a reasonably simple structure consisting of an outer layer, a middle layer, and an inner layer. The outer layer is just meant to protect the eye from all sorts of stuff in the environment and allow light to come into the eye so that we can see, so we can actually have vision. Then we're able to control how much light gets into the eye by the expansion, the dilation, or a constriction of the pupil, which is controlled by muscles that control the iris, the diameter of the iris, the colored part of the eye. And then we pass that light through the lens, which is responsible for sort of bending those waves of light so that we can project them onto the retina and see things clearly. We can have good visual acuity. And certainly each of these areas within the eye undergo some changes with age that ultimately will lead to changes in visual function. And we'll talk about those now. Some of the changes with vision and age that we see, we'll start with the lens, which is responsible for bending those incoming light waves or electromagnetic waves so they can be focused on the retina correctly, so we can then transmit that into an electrical signal which allows us to see. Well, the lens actually thickens and it stiffens. You can just basically think that a lot of things within the body end up kind of getting much more fibrous and less compliant with age. And the lens is one of those things. So we're not able to dilate or expand or contract the lens as well, and therefore we end up having problems with visual acuity, or the ability to see things clearly. Specifically, most older adults have problems with what we call presbyopia, the ability to see something close to the eyes. And therefore, many older adults need to have reading glasses or bifocals, which can affect other things that we will talk about later. Additionally, the lens tends to take on kind of a cloudy appearance. It starts to build these deposits on it. Those are what we call cataracts. Cataracts is Latin for waterfall, because basically when you're looking through a cloudy lens, it almost looks like you're looking through a sheet of water that's falling off of a waterfall. And that can result in major problems with visual acuity. People just will see pretty much a blurred field of vision rather than things clearly. And then finally, the lens kind of takes on a yellowed appearance. And what happens there is that it causes us not to be able to differentiate between electromagnetic waves, which we perceive then as colors, of different wavelengths. And for the most part, older folks start to have trouble differentiating blues and greens from one another. Then we take a look at changes to the cornea, which is that outer layer of the eye. It's typically a very thin and a clear layer, and it tends to thicken as we get older. And what that does is as light comes into the eye, it sort of scatters the light to a greater degree because it gets thicker. And that causes us to see more glare. And when you kind of combine that with the fact that the pupil, the muscles that control the pupil, don't allow the pupil to dilate as much, we don't get as much light in. The light we do get in tends to get scattered more. It really increases glare and causes problems, particularly with older people that drive at night. Most older folks I know do not drive at night because they have trouble accommodating low light conditions, and then when they see headlights coming at them, the glare from those headlights can really disturb their entire field of vision. Then finally, we have changes to the retina. The retina is the surface on the back of the eye, which includes the sensory receptors that absorb that electromagnetic wave coming into the eye, and then converts it to an electrical signal, transmits it to the occipital lobe of the brain so we can see. So we have both rods and cones. Rods are specifically related to or absorb those black and white electromagnetic waves, and then we have cones, which are responsible for us seeing the whole spectrum of color. And the primary thing that happens to rods and cones is that due to a reduction in blood flow to the retina, it needs a lot of blood because there are a lot of cells that need to be nourished. We typically see about a 25% loss of rods and cones by the time a person hits the age of 70. Ultimately, down the line, as the retina changes to a greater degree, we might actually even see certain disturbances right at the center of the field of vision. There's a portion of the retina where we have the highest concentration of rods and cones, and is exactly the point that we look at when we look at something directly. We call that part of the retina the macula. And the macula, for some reason, starts to undergo certain changes called macular degeneration. So some, not all older adults, but some older adults experience an especially significant loss of rods and cones at that point. And we also end up seeing basically a blip in the center of vision. So many older adults need to actually look slightly away from the object that they want to see clearly because the center of their field of vision is distorted to a great degree. Then finally, along with everything else in the eye is filled with kind of a gel-like substance called the aqueous humor. And that is this pressure that's exerted by that fluid. And as time goes on, most older adults have problems draining fluid and then replacing that fluid in the eye. And we can increase the pressure in the eye to such an extent that it begins to restrict blood flow to the retina and cause major visual problems. That process is called glaucoma, which happens in a fair portion of older adults. Moving on to changes related to hearing with older adults, we can see here a schematic of the ear. The ear has three primary locations. We've got the outer ear, which consists of the auditory canal, which sound waves come into. Then the outer ear is separated to the middle ear by the tympanic membrane, or the eardrum, which is a very thin portion of tissue that converts those sound waves into vibrations. In the middle ear, we have three bones, the hammer, the anvil, and the stirrup, which are responsible for transmitting those vibrations through the middle ear against what we call the oval window. The oval window is a portion of the cochlea, which is in the inner ear, a structure in the inner ear, which contains very microscopic fine rows of hairs, and the cochlea is filled with fluid. So as vibrations come up against that oval window, fluid moves around in the cochlea, and then those hairs will sway, essentially with the current, and convert those waves into electrical signals, which will then be brought by the cochlear nerve to the temporal lobe of the brain, so that we can hear things. Additionally, in the inner ear, we have the vestibular system, or the vestibular apparatus, which we consider to be the semicircular canals, which are also fluid-filled substances that have those rows of hairs. And then at the base, we have kind of a structure that we call the utricle and the sacculae. And those are also filled with hairs. And ultimately, the vestibular system kind of syncs with vision to give the head and the body, particularly the head, an idea of where its position is in space. And with age, the vestibular apparatus can become impaired. We'll talk about that in a little bit, and lead to some issues. So the functional changes that we ultimately see with hearing impairment include a loss of the ability to hear things clearly. About a third of people over the age of 65 years old have some kind of a significant hearing impairment, which allows them not to necessarily hear what's going on in the environment very well. Unfortunately, those hearing impairments typically are due to problems within the cochlea, within the innermost part of the ear, and they're somewhat resistant to amplification. In other words, if somebody wears a hearing aid, they might be able to hear noises at a louder degree, but they can't necessarily discern between, say, ambient environmental noise and somebody's voice. So they're somewhat resistant to amplification. And we notice actually that hearing difficulties are on the rise because many of our environments, many of our societies, with their technological advances, show that there are a number of more environmental noises that can cause initial losses of hearing and also can interact with our ability to hear things clearly. And certainly the ultimate result is that these hearing impairments can greatly affect communication and can make it very difficult for a fitness professional to communicate well with a client. So later, we'll talk about some strategies that we can take into account when we're working with a client with either hearing impairment or vision impairment. And those are really important strategies to know about. Then finally, we have changes in proprioception. I just talked about the vestibular apparatus, which exists in the inner ear, those semicircular canals. And those those semicircular canals begin to lose the ability to function well because those hairs that are responsible for being able to pick up information and then convert it to an electrical signal to the brain, they begin to fall off, fall out, and just not be as sensitive to what's going on within those semicircular canals as they were when a person were younger. So you won't see a lot of older people man on wire like we see in this picture right here. That would probably be a bad move. Additionally, along with the change in vestibular function, we see those changes in vision. And usually the vestibular system and the visual system communicate with one another to try to give an idea of what the body is doing and where the head is. And when they start to not communicate correctly or give different information to the brain, the brain gets confused and we end up getting a situation called vertigo, where a person will literally get a spinning sensation in their head and can greatly increase the likelihood of just a spontaneous fall for somebody. We also have many somatic receptors, or internal sensory receptors, that are distributed throughout the skin, throughout the muscle, throughout connective tissue, throughout joints. We've alluded to these already, and they kind of provide information to our central nervous system about the positioning of the body. And they provide good information for us to know perhaps when to and in what pattern we should activate certain muscles in order to accommodate changes in the body as the body goes through movement. Well, over time, these proprioceptive receptors become much less sensitive. They also are altered due to altered postural or statural positions of the body, and therefore we don't necessarily get very good information coming into the brain, and we can't necessarily respond to something that might be a stumble or a trip or a disturbance that somebody might have if they're bumped into as they're walking down the street. So all these things result in pretty significant balance and postural control deficits. So this has been maybe a little bit of a depressing presentation to listen to, but I assure you guys that there is very good news at the end of all of this. First of all, recognize that many of the biological changes that the body goes through aren't significant enough to truly affect function. The things that affect function to a larger degree would be sedentary lifestyles and chronic diseases, which aren't necessarily something that older folks have to deal with if they age successfully. What we see here are a couple of pictures of some of the people that I've worked with in my past. The guys on the top left are gentlemen which were in my golf fitness research study that was, I think, pretty much the first research study studying older adults going through a functional training exercise program. And they made huge strides from the beginning of the program to the end of the program. And then down at the bottom right is one of my community groups that I work with out in the community. And this is a group exercise program where not only do they increase their strength, their flexibility, and just their capability to enjoy life, but they also generated some great social relationships, and occasionally even a couple of these women dragged their husbands, and their husbands became part of class with them, and it gave them something to do together. So even the older body can improve. There are some incredibly interesting studies from the 1980s and the 1990s that were done by people like Walter Frontera and Maria Fiatarone that studied people who were very late in life, their 8th and 9th decade of life, and found that we could see literally huge, relatively to where they were starting, improvements in muscle strength and even muscle mass with age. And those changes, we have to recognize, are directly related to functional changes, their ability to improve their quality of life and function more effectively. So that's the good news. So hopefully what this will inspire you to do is want to go out there and work with older adults who are going to be coming to you, because in summary, we know the older adults are growing faster than any other segment of our population. We're seeing just unprecedented growth in the next 30 years. The health of older adults really needs to improve in order for just the economic fabric of our society to stay together, because as we increase numbers, healthcare costs will increase, so we must have older adults deal with their chronic diseases more effectively. And that's going to truly be tied to the lifestyle choices that they make, including physical activity. So they're going to recognize that they need physical activity, and by extension, they need us. Then remember, changes in the body with age require us to be aware of those things and pay attention to those things, and some of them we must consider very closely when we provide a safe and effective exercise environment, and we'll talk about a lot of those strategies a little bit later on. And then finally, always remember, even the older body can improve, and it can improve to very, very substantial degrees. Thanks very much.